Well, good afternoon and welcome. Thanks for coming. Everybody watched the keynote?
Yeah.
Liked it?
Yeah.
Liked what you saw? So you saw Mark swearing? I guess that's how I should lead it. So what do you guys think about Azure? How many of you have tried Azure? Okay. On-prem? Okay. Well, hopefully, you'll see, a bit more of Azure today. And we had a workshop yesterday. It was actually pretty good. And, I believe all that content is downloadable. So, if you want to, beyond this session, if you want to actually try out, more steps, feel free to go download it. You can shoot us an email. We'll be happy to help as well. So my name is Madhan. I'm the guy with the long name there. And this is Jeff, he's my colleague.
Yeah, Jeff Mendoza. I work at Microsoft Open Technologies, and I tend to work on Knife Azure, Azure Cookbook, and recently Vagrant Azure.
Right. And I'm program manager in Microsoft Azure, the core Azure group, and I specifically focus on working with our chef partners in onboarding, some of their IP on Azure. So hopefully, you'll get a slice of what Azure is about, since many of you, you haven't tried Azure. So I wanted to kind of start out with some basics. This is probably common knowledge, but it's helpful in terms of introducing some of the terminology that you would see when you go out and try Azure. So Azure, just like any other cloud provider, we have a global footprint. We have regions, and within regions we have what we call as clusters, and this is where your VMs run, your compute network and storage resources that you create, in Azure, essentially are physically located in one of these machines, even though you don't get to see it. So if you go through, a portal experience or a command line experience of creating a resource, you typically would be asked, information about which region do you want to create, the storage account or compute or whatnot. So in general, think of it as, we basically have these notions of data centers, multiple data centers per region, and then multiple regions. As of today, you can see this is a screenshot from our portal. You can see this in our API listings as well. So if you list the regions, we have about 12 regions, and by the end of calendar year 2014, we'll have up to 16 regions worldwide. So you can essentially deploy your code, anywhere in this global footprint. And then you have this notion of cross-region connectivity that you can then take advantage of, right? The next concept or terminology is really this notion of virtual machines. So everybody knows virtual machines, especially folks who have used Windows and Linux virtual machines on-prem. You get your own execution environment. You get to do what you want to do there. In the cloud, in Azure specifically, we have primarily two flavors of virtual machines. One is the virtual machine that that you get to control. Once you create a virtual machine, the platform doesn't interfere with what's happening in there, what's installed in there. That's your classic infrastructure as a service on your right. And you can have one virtual machine, or you can have more than one, a multi-tier application, connect them up together. And we wrap them up into this notion of what they call as a cloud service. And a cloud service is simply, think of it as a unit of management. Right, you want to deploy a multi-tier application, right? A database backend, a mid-tier, a front end, and you want to manage things together. If you want to roll, code updates, you want to do it such that this entire application is still running as you deploy your update. So the notion of cloud service is to allow you that management entity, so you can do a certain set of operations on the cloud service that will impact all the virtual machines in that cloud service. Now we also have another version of virtual machines called web roles and worker roles, and these are essentially stateless virtual machines. And what that means is these virtual machines are running a special flavor of Windows. Today it's just Windows only, Windows and the guest. And any application that you run in those virtual machines are supposed to be stateless. And the reason we are asking that, this is a programming paradigm, where if that virtual machine were to die, because of planned downtime or unplanned downtime, the hardware crashes, or we are servicing the platform, we are able to kind of spin up another virtual machine, and have the same code running, and your application continues to run as is. So these are meant for stateless applications. This is our platform as a service for our compute services, right? So that's kind of the top level, terminology and concept that you want to kind of understand. We also have two versions of that stateless virtual machine within, which is one is a web role, which is primarily think of it as a IIS, as a service, and then a worker role is essentially any code that you can write on a Windows virtual machine, right? And then the next concept is affinity groups. So affinity groups, think of it as a notion of a logical grouping of your resources, right? You're creating compute, you're creating storage, you're creating a bunch of databases, websites, and you want them to be together. I mean, these are fundamentally, from your point of view, part of your application or service, and you want to manage them together. Again, this is a logical view from a customer point of view to group resources, and it implies certain things to the platform. It tells the platform to optimize for best co-location of these resources. Say if you have a virtual machine and then you have a storage account, your compute and storage, if you keep them apart, say for example your storage is in Europe and your compute, your VM is in West US, right? Like in one of our data centers there. Clearly, any operation that you're doing within the virtual machine, it has to go all the way to Europe, right, across continent to kind of access that storage. So it's not optimal either in terms of simple lifecycle management or performance, right? Applications care about performance. So affinity groups, that's an important concept. You'll see even if you use the knife Azure plugin that we have, these are some of the common concepts that if you do just a knife Azure, creating and deleting a affinity group is one of the supported commands. I just had a screenshot from the portal. I'll quickly show you guys what this looks like. And then virtual network. Virtual network is it's an accompanying concept. And if you're running an enterprises, on premises, you care about a trusted, secure boundary that you want to extend into virtual machine, extend into Windows Azure resources. This is where you set up your virtual private network. Right, you probably have an on-premise router where you can reserve a set of IP addresses that you can use for identifying your Azure resources, and then essentially it's a private IPsec based trust boundary that nobody from internet is able to access except you, right? So we have this feature available as well, and the biggest value prop here is the security isolation, right? Like for enterprises, especially dealing with secure data, you obviously want to make sure that it's in an IP range that nobody else can see. All right, so actually before I go here, let me quickly show you in portal what this looks like. So this is our portal. If you haven't tried Azure, it's quite easy. Just if you go to manage.windowsazure.com, I've already signed in here. You'll have a sign up link, and we have a free trial that's perennially running. You get up to 200 hours, like what Mark Rusnovich mentioned in the keynote today. So once you log in, this is a typical view. You basically have all your resources that you can create. Websites, virtual machines, mobile services, storage, SQL databases. So obviously for this audience, you guys are very interested in creating a virtual machine. So I'll quickly run through how you would do that. Mark showed this in the gallery as well, but I'll quickly show you a couple of examples here. So you could create a virtual machine two ways. One is a quick create. This is where you don't want a wizard-like experience. You know exactly what you want. You want to quickly script this out. Or a gallery where you're actually wanting to browse from the curated content we have in our platform gallery. So you can see there is some first-party content that comes from Microsoft, and then obviously a bunch of third-party content. And these are publishers who work with us, who curate this content, who support this content, who refresh this content on an ongoing basis. So you got Ubuntu, CentOS, SUSE, Oracle, and obviously Puppet and Chef here as well. So if you see here, if I start creating a VM, my resolution is a bit all right. So if we go through this experience, right? So and I can have a pick of the size of the VMs, and you'll notice here there is an option for tier that says basic and standard. So this is a fairly new capability that we introduced at the Build conference actually last week. So we have this notion of a basic set of VMs and a standard set of VMs. The biggest difference between these two tiers is in basic, it's much cheaper for less predictability in terms of performance, right? So this is primarily meant for your dev test scenarios, right? Where you want to really spin up a VM, do a bunch of testing, and then you spin it down, right? So think of it as, where you do a lot of your dev test, staging type testing, and then when you switch to being in production, you want more reliability in terms of performance, and you move to a standard tier, if you will. The interesting thing is, both in basic and standard, you get the same set of choices, or mostly the same set of choices in terms of virtual machine sizes, right? So if you look in basic, here are the different virtual machine sizes you got. If you look in standard, we have slightly a bit more, especially our high memory, memory intensive VMs, if you will. So you just pick one, like the joke that Mark cracked, we won't use SSL, but you can always use your good old password. I type in my password. Actually, you know what? I'll create a Windows virtual machine, given that Mark already showed a Linux virtual machine. So at least you guys can see the Chef integration there. So I pick a Windows server. I go through the same steps. Chef. Pick this. Then I say next. You have a set of options. We talked about the cloud service. Here's the option where you would specify if you want to implicitly create a cloud service, which is essentially again a grouping. You pick the region. We talked about this, right? All the different regions that it's available. I had created an affinity group. I could choose to say just deploy in that affinity group, and in my case, it's essentially in East Asia. So I'm telling explicitly my VM, storage, everything should be in that affinity group. I'm telling the platform, automatically create a storage account. I could choose to say, use one of those storage accounts that I already created. Availability set is the notion where if you have multiple VMs in your application and you want them to be spread across, different, you want them to be highly available. So, say for example, you have a database backend, right? You're running MySQL, SQL Server, it doesn't matter. And you want it to be highly available, much more so than what a single VM can provide. So typically the way folks do it, you'll have multiple replicas of that database that are concurrently running, and you place them into different fault domains. And by fault domains, I mean you don't want the platform to take all these replicas at the same time, right? So in Azure, we express this concept through what we call as an availability set. So you can place a bunch of VMs on different fault domains, and the platform would place them for you, right? So I can create an availability set here, and then if you create multiple VMs, we'll take care of the placement for you. So I've got remote RDP turned on. I got PowerShell turned on. What's my next? All right. And here's where, we talked about this notion of VM agent. So this is a very light bootstrapper process that, we have in Windows, and we announced for Linux as well. And, you have a variety of extensions that are being available today, a lot of first party as well as third party. And this is the same experience, what Mark showed you this morning, right? Like, you pass in the, especially from a Chef point of view, this is essentially designed by the Chef team in terms of what are the common parameters that you would need. You would pass this information, and then you just get going, right? I won't create a VM here because it takes like 5 minutes. So that's kind of a quick tour of the portal. I mean, I'd encourage you to, get a subscription and try it out. At least to get a sense of what creating a VM in cloud looks like. And then just a couple more slides before I hand over to Jeff. So this slide is essentially talking about the networking concepts, right? So Azure as a service is providing some of the common networking features, essentially as a service, right? Like, so a couple of examples are using our load balancers that you can use it as a service. There is two capabilities that are commonly used in our virtual machine features. One is port forwarding, where say you have multiple virtual machines in your deployment, and you want to be able to through your public facing IP address say, I want traffic on this port to go to a particular virtual machine, traffic on this port to go to a different virtual machine. And this is essentially what the picture is conveying you. So you have this concept of a public port and a private port that you can utilize to program this. So from a load balancer point of view, you're basically having two public ports, 5586 and 5587, but internally you are mapping them to different virtual machines, right? So This is something that you can just get by creating a couple of VMs in the Azure portal or command line. And then we also have this notion of load balancer. This is a pretty cool thing where if you have, say, for example, a database or a front end, you're able to, for the same port, the platform can allow you to do some sort of a round robin mechanism to, direct traffic, right? Mark used to show this demo where he basically has a SharePoint form as an example with a database backend, and you basically write some business logic to say what is the criteria for you to kind of direct traffic from one backend server to the other. And it's the same port. By default, we support round robin. We can also enrich your direction mechanism through health probes. So you can write a small health probe logic that would be called from the load balancer to say if that particular backend is healthy or not. And based on that, we'll either redirect the traffic, or we would say, oh, this is dead. I won't redirect the traffic. So, so this is just a slice of what you get from a networking point of view. Yes, question.
Your load balancers are capable of load balancing amongst zones?
It's coming soon, would be my answer. So today we don't support that, but very, very soon. So we will have this ability. So the fundamental feature that you need is to be able to create a virtual network across zones. Now customers do this it's not that it's not possible. I mean, but it puts a burden on the customers to be able to kind of do this redirection between. But to do it seamlessly, you'll see this pretty soon, in a matter of actually a month or so. Yeah. All right, so I figured I'll also kind of show a slide on what it looks like to kind of peek inside a VM. So once you create a VM, you would actually see two disks, by default. One is your C:, where you basically have your OS boot disk, if you will, and then we have another drive which is supposed to be an ephemeral drive. It's a temporary disk. This is where you put your scratch files. The difference between these two disks is, or all disks in virtual machine, the C:, which is what we call as persistent disks, are actually backed by our Azure storage blobs. So anything that you do within that virtual machine that you write to that persistent disk, we are actually doing a sort of a continuous write back to our storage blob. So it's guaranteed that, say, for some reason you shut down the machine or the VM crashes, when it comes up, when we bring that virtual machine up, you would get it back to the last known good state, which is what you would expect, right? On a virtual machine running on premises, you have full control. So the idea is to kind of mimic the same exact behavior. The temporary disk, the reason that exists, it's a part of it is a legacy from our platform as a service offering. The reason that exists is a lot of applications want faster local drive access. I apologize, I don't know it went. And this is the reason for example, Windows page file. You could potentially put it out there, right? So if the VM crashes or you reboot the machine, it's not that you care about persistence of that particular file, right? So a lot of applications require local disk access. These are actual local disks that are exposed to the VM, the local to that physical machine that the VM is basically incarnated into, right? And then optionally you can attach multiple persistent disks. We call them data disks because it's not where the operating system runs. And depending on the size of the virtual machine, we have a number of data disks that you can attach. And obviously, when we went through that experience, like what I showed in the demo, you're picking up a Linux image or a Windows image. That's the VM. I mean, that's the image that will be used for booting up that VM. That will be sitting on your C:, and then you got your options for data disks, if you will. And this is again the same information. It has some more details. Our OS disk today, it's 127 gigs. Data disks can be up to a terabyte. Like I said, both OS disk and data disks are persistent. They are backed by our storage blobs. You can have, in the largest virtual machine that we support, you can have up to 16 disks, which means you can have up to 16 terabytes, right? And then the temporary disk, we talked about it. This is ephemeral. It's really meant for state that you don't care about discarding. And this is just a smattering of the VM sizes that we have. Like I mentioned, basic and standard. Our naming convention goes from A0 to A4, and on standard we go all the way up to A7. And we obviously keep introducing new, bigger VMs as customers demand for it. You will see in the next couple of months, we'll introduce a couple more additional sizes for infrastructure as a service. Any questions so far? All right. So this, I believe, is my last slide before I hand over to Jeff. So we talked when Mark talked about this extensively in the keynote, right? So this notion of VM agent. So VM agent, the legacy of this particular capability, this comes from our platform as a service, where we do the application lifecycle management for you. The trade-off is you can't log into the VM and do whatever you want to do. So in infrastructure as a service, you get more control, but you own the management. So this blending of IaaS and PaaS, what it really means is we want to take some of the best value proposition of our platform as a service and incrementally bring it to our infrastructure as a service. And this is one example, right? The ability to kind of run the same agent that essentially can extend the capability of the VM through either first-party software or third-party software like Chef's own ecosystem to bring in this rich manageability experience to within the VMs, right? Whether you're doing automated deployment, whether you're doing VM management, all of that is possible. The cool thing about this particular technology is it supports auto updates, right? So this is again a value proposition of a PaaS environment. Even in Azure, when we introduced web and worker roles, this is one of the key value props, right? The updates for the applications and the execution environment is automatic, right? Without having the user to actually go and specify certain things. And then it's a secure access to the platform. One of the common requirements we get from customers is when they want to deploy applications within Azure, they worry about where it's pulling the data from. Is it secure, right? Sure, we support a lot of package managers today. You obviously can deploy stuff from GitHub, but typical on-premises enterprises, they want everything guarded, including the IP. So in this case, what happens? This platform repository that we are referring to in this picture, this is managed by Azure, right? So this is heavily ACLed content that we work with a curated set of publishers, right? Obviously like Jeff. Who we have a good brand reputation as well as protection of their own IP, and we use that mechanism to kind of distribute the content, right? So this agent essentially talks to this internal storage account and downloads the content, and this content is approved by the publishers, validated, supported, tested, if you will. And then once it's there, the ecosystem just lights up. Whatever you do with your Chef ecosystem, the commands, you're essentially good to go in Azure. So, and we talked about the announcement this morning. So our goal in terms of Chef integration is to have parity in terms of whatever you can do in Windows VMs. You want to be able to do the same thing with Linux VMs. The one differentiation point, I got this question in the workshop yesterday. Hey, it's like, hey, how is it different than Amazon? Yeah, we got Chef there, we got Chef here. The one thing I would say there is the injection technology that we have, the VM agent technology. For example, in Windows, our technology allows you to be able to inject, like for example, the Chef software on any VM, regardless of the image, right? Like whether it's an Oracle Windows image or Microsoft's own image or a community image or my own image that I uploaded, right? It doesn't matter. I don't have to go muck with the published image, go inject additional software, bake it again and deploy it. If it's a running VM in Azure, we are able to kind of inject it. Now, we are trying to shoot for something similar in Linux as well. It won't be immediately, but that's kind of our goal. And we believe that decoupling of the image content provider and the extension content provider allows for a lot of composition to happen. So you don't get into this image sprawl problem, right? How many of you have seen this where I have I have 10 AMIs or 10 VHDs, and every time I make an update, I have to create a repository of VHD images and manage, curate them, and it's a big problem, right? So that's something that we believe is differentiating. All right, there's one second. I find my mouse. All right, so this I'll just skip through. This is the slide that you saw from the keynote today, just for completeness. The real takeaway from this is, in Azure we try to be as open and flexible as possible. There is first-party, capabilities, but also rich third-party capabilities that you want to make sure that if you're a developer, you're successful with whatever your choice is. And same in terms of the configuration management software, we talked about it, identity, monitoring, autoscale. The idea is you can compose whatever services that you want, and they can all work together and sync together, if you will. All right, I'll switch to Jeff, who can now show us demo.
Cool. Okay, so yeah, I wanted to give you guys a demo on some of the work that I've been doing lately on Vagrant Azure. So how many of you guys use Vagrant or know about it? I think it's cool. How many of you guys have never ever heard of Vagrant or used it at all? Okay, so you should be able to follow along then. Great. Okay, so here is our GitHub repo for Vagrant Azure. It's in our MS OpenTech organization. And here's the README, tells you how to use it. It's a standard Vagrant plugin, do Vagrant plugin install. So I've got Vagrant already installed on my machine. And I've already got the plugin installed. I actually have a pre-release version of the plugin. I made some fixes, last night for the demo. Not quite last night. But we're actively developing. We're not done. We're sanding those rough edges as we speak. Okay, so if you want to use Vagrant, you normally need to create a new directory. So I'll call it a new VM or something like that. And you do a Vagrant init, which creates you a Vagrant file. And Vagrant puts a bunch of boilerplate in here. So the first thing I want to do is set the box. And let's say I want to use Ubuntu LTS. But wait, do I have an Ubuntu LTS box? What is the box? So the box is the base image that you want to use for your Vagrant file that you're going to write. For Azure, we're not publishing any base boxes yet, but they're really easy to create because you don't actually you want to create a base box that normally points to an Azure image. So I have a base box here that I created, and they're pretty simple. Metadata.json just says provider Azure, and you can have a Vagrant file inside your base box that sets some defaults for you. So I created a base box for Ubuntu LTS. I gave it a VM size of small and the actual Azure platform image that I want to use. You zip that up into this Ubuntu LTS Azure box. So right now it's not installed, so let me go ahead and install it. Oops. Use the wrong command. Okay. Oh, so there's my Ubuntu LTS box for Azure. So your base boxes are specific for your provider. So let me go back to my Vagrant file. So I've got my box now that I want to use. Let's see what to do next. Okay, so for Vagrant, it typically has a lot of sane defaults. So normally you don't have to put a lot in your Vagrant file to get a machine that's whatever somebody decided was a good idea for all the default settings. That works fine if you're using it with VirtualBox or some other local hypervisor. But for Azure, you need to provide it your credentials, and there's some other minimal configuration you have to do. So here in our README, we have some example of the minimal plus a whole bunch of other configuration that you could do if you needed to. So I have my settings here. I'm going to paste in. So this is my management certificate that I've downloaded from my Azure portal here, and the endpoint and subscription ID. There's an easier file to use that's one setting instead of three, which I'm working on getting it to use that one as well. So those are one of those rough edges. So there's a couple more things you need to set before you actually go ahead and create your VM, other than your credentials. Oops. I'm going to give the VM a name, and that's going to be used for the cloud service name as well. And I want to tell it the location. And just like I showed you that you could create a base box with the image, you could put some of these things that you use often in your in a box image, and then load that into Vagrant. Let's see. Okay. The other thing I like to use is an SSH key. And Vagrant comes with one, an insecure one built in, but you wouldn't want to use that for your cloud VMs. Right now, Azure, instead of using just your plain SSH private key, it needs an actual certificate, which is a bit of a pain to do. Right now in Vagrant Azure, we don't have the ability to generate that, but that's something I'm adding as we speak as well. So that's another rough edge. So this cert file here it's a few different commands to run if you wanted to try it out today, but hopefully I can have that fixed. And yeah, that's what I want for now.
Can you put it in the README of the that?
Let's see. Yeah, I have that documentation somewhere else for a different project that I could put in this README too, for now. But yeah, I want to have it quick fixed soon. Okay, so I think we're ready to do a Vagrant up. Does this look good to you guys? Let me go back to the directory. What did I call it? New VM. Oh, I need to give it the provider. Okay, so while that's running, I'm going to go back to my Vagrant file. And so I'm going to create a VM, but now what do I want to do with it? Of course, I want to use Chef, right? So Vagrant gives you all this, like I said, boilerplate to use Chef. I decided to use Chef Solo. Oops. So you can see the examples here. I have a basic cookbook that doesn't really do anything, just to test it out. I'll show that to you if you want to see it. Sorry about that. What did I call it? Starter? Yeah, so I'm just going to drop down a file and see if Chef works. Are you guys tweeting it? Are you guys tweeting at me? Okay. Yeah, so, but this isn't going to work because Chef isn't installed on the machine. So we also want to use the Vagrant shell provisioner to put Chef on. Oops. So this is just, we're going to use shell only for installing Chef, and then going to use Chef to do whatever we want to do with our cookbook. Let's see. Okay. Let's see how our VM is doing. It's taking a while. One of the things here is that we're adding the VM to a new cloud service. So if you add some other settings, you can add the VM to an existing cloud service if you want to have multiple VMs inside of a cloud service. Any questions while we're waiting for the machine to boot up? Yeah. Uh-huh. Yes.
Like the AWS plugin, as we parsing or something.
Yes.
Talk
Yeah, so we do the same thing as.
Can we repeat the question?
Oh, okay. Yeah, so the question was, one of the cool things about Vagrant is that it automatically does the shared folders for you. And by default, it's going to share the directory that your Vagrant file is in with the guest. You can add config to share other directories. VirtualBox does it more of synchronized because it's a feature of the virtualization software. So for Vagrant AWS, it uses rsync, and Vagrant Azure uses rsync as well. And that's for Linux VMs. For Windows VMs, we'll be using WinRM to copy the files over. So the machine is provisioned, it's ready, looks like it's booting up, we're waiting for SSH. And there you can see the rsync folder. So if you don't know Vagrant SSH, you just type it in the directory that your Vagrant file is. It knows which machine, what your login is, where your SSH keys are, does everything for you. So here's our Vagrant file. So I'm going to save those changes I made for provisioning. Oops, where were they? I normally delete a lot of this stuff. And run Vagrant provision. So if your machine's already up and you want to make some changes just to provisioning, you can run Vagrant provision to do that. There's also Vagrant reload. We'll reload some of the other settings. So for Azure, it's going to shut down and boot up the machine. So here we're running that shell provisioning. And if you run Vagrant provision over and over, it's going to run this over and over too, the shell provisioning. So it's not quite smart. So it'd be cooler if the install would kind of go a little bit faster if it already had the right chef installed. But I don't know if you shouldn't be running provisioning a lot, I guess, on your Vagrant box over and over. Okay, so chef was installed and then it ran. Let's check it out. Yep, there it is. So let's say I finish playing around with my machine. I want to shut it down. So we don't. Vagrant has suspend and resume. We didn't implement that for Azure, so there's no analog in Azure for that. But Vagrant halt is going to shut down the machine, and it's actually going to deallocate it once it's stopped, which means you stop getting charged. Let me refresh. Yep, there it is, stop deallocated. And then when you're all done, you can do a destroy, which is going to delete the machine and all the stuff it created in Azure to support it. Yeah. All right, well, that's the end of my demo. Any questions?
So do you know when support for things like the Linux integration available for Azure packages?
For Azure, what?
As opposed to Azure Pulpit, or the Azure packages?
Oh, okay. Do you know?
So can you repeat the question?
Yeah, just looking for, we're running an internal cloud based on Azure.
Oh, you mean private cloud?
Yeah, right.
Okay, so the question is when would we get the same level of integration with a private cloud? Now, Jeff, you did some work for Hyper-V, right?
Yeah, we do have Vagrant Hyper-V, but yeah, that's not what you're asking. You're saying like the Linux integration and
Linux integration, but actually,
Okay, cool.
because that's still
Yeah,
what I'm saying.
yeah. So check out Vagrant Hyper-V if you want to as well.
And that's available in Git as well.
Yeah, it's on our MS OpenTech GitHub site.
Yeah, the other Linux integration, I think, I mean, I was talking to someone else in the booth as well. our server ship cycle and the cloud ship cycle obviously is different paces, right? So I mean, this is one of those areas where we lead with public cloud, especially in terms of our Linux integration projects, and it typically catches up in the the next server life cycle, if you will. And there are cases where the server team, the Windows Server team, would make changes farther than us, and then the public cloud would catch up. So the Linux integration, I would say you would first see this for public cloud, and eventually it will be in one of the server releases. Any other questions? How many of you are gonna try out Azure? That's really our goal. I mean, I have just one slide, as you saw this. There are some links here, just really easy to go try it out. It just takes a few minutes. You have $200 worth of Azure services that you can go try out. Really dev test. I mean, try it out for a dev test scenario, right? You'll get a sense of what works, what doesn't work. If it doesn't work, send us a mail. Try out Chef on Azure. We've been working with Chef. If you already have systems, again, start for dev test. If you want a Linux VM, Windows VM, it doesn't matter. It's a steal in terms of the price. And we also introduced this basic VMs, which is much even more cheaper. So try it out. Give us feedback. We'd love to hear from you. All right.
Thank you very much.
Thanks.
Thanks, guys. Thanks, guys.